Hello everyone. Today our new topic is probability. Now, don't skip the video, for I am coming up with 7 brand new examples which are very student friendly. So let's hop into the topic. First is important facts and formulas. Now, first is experiment. What is an experiment? An operation which can produce some well defined outcomes is called experiments. Okay? Next is random experiments. An experiment in which all possible outcomes are known and the exact output cannot be predicted in advance is called a random experiment. For suppose if we take a coin and if we toss it, okay? We know that the probable outcomes is either a heads or a tails. So on the experiment of tossing a coin, the probable outcomes are known because we know that either a heads will occur or a tails will occur. And the exact output cannot be predicted because if we toss a coin, we exactly don't know whether on tossing the first coin or on tossing the coin, heads will occur or tails will occur. So which cannot be predicted in advance is called a random experiment. Now some examples of performing a random experiment. First is rolling an unbiased dice. What is unbiased? Unbiased is a dice has 6 phases. Every phase has 6 numbers, like from 1, 2, 3, 4. No two phases are equal. That is known as an unbiased dice. So on rolling an unbiased dice, we know that the outcomes would be either 1, 2, 3, 4, 5, 6. But if we, roll a dice, then we exactly don't know either a 2 will occur or a 5 will occur or a 6 will occur. That is what probability is, and that is what random experiment is. Next is tossing a fair coin. A fair coin means, as I said, an unbiased dice. So a fair coin is one side is heads and another side is tails. No two side is heads or no two side is tails. So tossing a fair coin. Third is drawing a card from a pack of well shuffled cards. Okay, like you can pull out a card and you don't know whether it's a diamond or a heart or anything. Picking up a ball of certain color from a bag containing balls of different colors. Now suppose you are blindfolded and a bag is given to you with 5 different colors of balls. You are said that you need to pick a ball. So you actually don't know whether it is a blue ball or it is a green ball or either a green ball is there. So that is a very random experiment. Now details are given. The first one is corresponding to the first one. So rolling an unbiased dice. What is the detail? When we throw a coin, oh no, this is for the second one. Tossing a fair coin. So when we throw a coin, then either a head or a tail appears, as I said. Second is a dice is a solid cube having 6 phases, marked 1, 2, 3, 4, 5, 6 respectively. So when we throw a dice, the outcome is the number that appears on its upper phase, as I said. Now the third is for drawing a card from a pack of well shuffled cards. A pack of cards has 52 cards. It has 13 cards of each suit, namely spades, clubs, hearts and diamonds. So cards of spades and club are black cards and cards of hearts and diamonds are red cards. There are 4 honors of each suit: ace, kings, queens and jacks. So they are called face cards. So these ace, kings, queens and jacks are called face cards. Okay. Now 52 cards can be divided into 4 classes of cards, 13 of each. 13 cards of spades, 13 cards of clubs, 13 cards of hearts, and 13 cards of diamonds. Okay? Now 3. What is a sample space? When we perform an experiment, then the set of all possible outcomes is called the sample space. Now for tossing a coin, the sample space is heads and tails. For rolling an unbiased dice, the sample space is 1, 2, 3, 4, 5, 6, because those are the actual possible outcomes of either tossing a coin or rolling a dice. So examples of sample space is, in tossing a coin, the sample space is head or tails, because the sample space is the set of all possible outcomes. So on tossing a coin, the possible outcomes are only head or a tail. If 2 coins are tossed, now simultaneously if we toss 2 coins, then either a head will occur. Suppose for 1 coin, if I toss 1 coin, a head has occurred. And suppose on tossing the second coin, a tail has occurred. So a head tail will occur. Now on tossing the first coin, if a tail has occurred, then on the second toss of the second coin, a head has occurred. So what are the possible combinations? Either 2 heads occur, or a head tail occur, or a tail head occur, or a tail tail occur. So these are the all possible outcomes. Okay. On rolling a dice, on the upper face, either we can see 1 or 2 or 3 or 4 or 5 or 6. So the set of all possible outcomes is actually 1, 2, 3, 4, 5, 6. Okay. Now the fourth is event. Any subset of a sample space is called an event. Now if we take a subset of this S on tossing a coin, either it is H or it is T. So that on any subset of the sample space taken is known as an event. So occurring a head on tossing a coin is an event, and occurring a tail on tossing a coin is again an event. Okay? Probability of occurrence of an event. Let S be the sample space and let E be an event. So E is actually a subset of S, which is written here. Okay? Now what is the probability of an event? The probability of an event is actually number of elements in an event by number of elements in a sample space. Okay? Now results of probability. These are very important results for probability. The first is P of S is equal to 1. So it can be said that P of S is the sample space. The probability of the whole experiment is actually 1. Now the probability of any event is ranges between 0 and 1. The probability cannot be negative. Now tossing the coin, either a heads will occur or a tail will occur. So probability of getting a heads is actually 50-50 and getting a tails is actually 50-50. Okay. So either a heads will occur or a tails will occur. But there is no negative probability because we know that the outcome will be either a head or a tail. There is nothing negative in that. So probability of every event is actually greater than 0, which is positive. And it ranges between 0 and 1. It can be equal to 0 or it can be equal to 1. But not negative and not greater than 1. Okay. Now probability of phi. Phi is null event. Like if I give an example of saying that a dice has been rolled, then what is the probability of getting a 7? Now that is a null event, because if I roll a dice, the outcomes are either 1, 2, 3, 4, 5, 6. So 7 can never occur. Since it can never occur, so that event is actually a null event. So probability of a null event is equal to 0. Now the fourth result here says that for any events A and B, we have probability of A union B is equal to probability of A plus probability of B minus probability of A intersection B. How is that? Now suppose this is A and this is B. This is called a Venn diagram. Okay? So this intersection part is actually A intersection B. Now if I consider A union B is A along with this B. So A union B can be written as A, this whole thing A, plus this whole thing B, the whole of B. Now if I consider A once and B for the second time, this intersection part comes actually twice. So we are subtracting A intersection B. Okay? So that this part actually comes once and we get A union B. Now if we put probability on both sides, what do we get? Probability of A plus probability of B minus probability of A intersection B. Hence we can say that we have derived this formula. Now A bar denotes not A. Then P of A bar is equal to 1 minus P of A. Since I said that probability can never exceed 1, so the probability of the whole sample space is equal to 1 here. Now probability of A bar, if probability of A is something, I say 1 by 2, then probability of A bar is actually the complement of the probability of A. So it is actually subtracted from the whole probability. Like probability of the whole sample space minus probability of A is actually the probability of the complement of A, which is probability of A bar. Now we come on to the solved examples as I promised. Example 1. In a throw of a coin, find the probability of getting a head. Now if I throw a coin, then probability of getting a head is actually 50%. We know that. But mathematically we can say that S, that is the sample space. Now on tossing a coin, either the outcome is a head or a tail. So all possible outcomes is actually the sample space. Here it is actually head and tail. Now E is that event where we are getting a head. So we need to find the probability of E. That is, we need to find the probability of getting a head on throwing a coin. So from this formula we can say that the number of elements in E by number of elements in S. So probability of E, that is probability of getting a head, is equal to number of elements in E. What are the number of elements here? 1. Number of elements in S is equal to 2. So half. Done. Now the second one. Second one says 2 unbiased coins are tossed. So 2 coins are tossed simultaneously. The question is, what is the probability of getting at most one head? That is, we are tossing 2 coins. We first need to find the event where there is at most one head. That is, at least one head is present in that event. Then we need to find its probability. So what is the sample space? We are tossing 2 coins. So on toss of the first coin, either we can get a head, or on toss of the second coin, we can get a head. So we can get a head. Now we can also get a head tail. We can get a tail head, we can get a tail tail. Now we are to find that event where at most one head is present. So E is that event where at most one head is present. Now out of this, on what elements at most one head is present? From the first three elements we can say that at most one head is present. Here are two heads, so at most one head is present. Here is HT, so one H is present. Here is TH, so one H is present. But on TT, tail, no head is present. So the set of all elements which is actually forming an event is actually, sorry, this would be actually head. Okay, head, tail, and tail head. So total number of elements in E is actually 3 and total number of elements in S is actually 4. So probability of E is 3 by 4. Okay, the third, an unbiased dice is tossed. What is the probability of getting a multiple of 3? Now, what are the multiples of 3? In the timetables, we have seen that 3 into 1 is a 3, 3 into 2 is a 6, 3 into 3 is a 9, 3 into 4 is a 12. So 12 is actually a multiple of 3, because if we multiply, now multiple comes from multiply or multiplication, like that. So multiple of 3 is, if we multiply some term with 3 and we get a term, then that is known as multiple of 3. Okay, so 12 can be said as a multiple of 3. Now, an unbiased dice is tossed. So, the sample space or total number of outcomes is equal to 1, 2, 3, 4, 5, 6. Okay, now E is that event where we get a multiple of 3. Now, from here, what are the multiples of 3? 3 itself and 6. No other terms are actually multiple of 3. So the event that is formed is actually 3 and 6. So probability, we need to find the probability of getting a multiple of 3. That is, we need to find the probability of the event E. The probability of E is actually total number of elements in E, which is actually 2, and total number of elements in S, which is actually 6. So 2 by 6 is 1 by 3. Now coming on to number 4. Number 4 says, in a simultaneous throw of a pair of dice, find the probability of getting a total more than 7. So if I throw a dice once, the total number of outcomes is 6. Now if I throw a dice twice, so the total number of outcomes is actually 6 into 6, which is 36. So the sample space is actually, the total number of elements in the sample space is actually 36. Now, what is the event? The event is getting a total more than 7. So we need to take a sum of the outcomes and get a more than 7. So let us see the event. The event E is actually event of getting a total more than 7. So what are the ordered pairs on addition which gives me more than 7? 2 and 6. 2 plus 6 is 8, which is more than 7. 3 and 5. 3 plus 5 is actually 8, which is more than 7. 3, 6. 3 plus 6 is 9, more than 7. So every ordered pair here on addition gives more than 7. So total number of elements in E is actually 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So what is the probability of the event that is required? Total number of events by total number of elements in the sample space, which is actually 36. So 15 by 36 is 5 by 12. Now number 5. Number 5 says a bag contains 6 white and 4 black balls. So a bag has 6 white balls and 4 black balls. Now 2 balls are drawn at random. So if you are drawing balls, you need to draw 2 balls at once. Then find the probability that they are of the same color. So we need to find a probability that when we are drawing two balls, they are of the same color. So the two balls are either white or the two balls that we are drawn is black. Let S be the sample space. Then total number of elements in the sample space is, what is the total number of balls? 6 plus 4 is equal to 10. Now from the 10 balls, we are actually drawing 2 balls at a time. So the total number of elements in S is equal to the number of ways of drawing 2 balls out of the total balls, which is 6 plus 4. So that is 10C2. C is actually combination. If you don't know what is permutation and combination, then I have a video in my channel. Please go and check out. 10C2. So 10C2 is actually NCR is equal to n factorial r factorial is to n minus r factorial. So this simplifies to 45. Now let E be the event of getting both balls of the same color. That is the event that is required. So the total number of elements in the event E is actually the probability of getting 2 white balls at a time is if we pick 2 balls from the 6 balls or 2 balls from the 4 balls. So 2 balls out of 6 balls or 2 balls out of 4 balls. So if we take 2 balls out of 6 balls, that is 6C2, or if we take 2 balls out of 4 balls, that is 4C2. Now since we are having an OR, so we are adding. This on simplifying gives 21. So now what is the probability of E? The probability of the event that on drawing 2 balls we get the same color balls. That is P of E is equal to total number of elements in E by total number of elements in S, which is 21 by 45. That is 7 by 50. Okay, now 6. 2 dice are thrown together. What is the probability that the sum of the numbers on the two faces is divisible by 6, is 4 or 6? Now as before, this one, the total number of elements in an sample space is actually 36, because on the first throw of a dice we get 6 outcomes and on the second throw of the dice we get 6 outcomes. So 6 into 6 is actually 36. Now E is that event such that the sum of the numbers of the two faces is divisible by 4 or 6. So now for these ordered pairs, look at these ordered pairs. 1 plus 3 is equal to 4, which is divisible by 4. Now 1 plus 5 is equal to 6, which is divisible by 6. So we need to find those ordered pairs out of the outcomes of the 36 outcomes such that they are divisible by 4 or 6. Now how are these ordered pairs formed? Now on the first throw of the dice, suppose we get to see that 2 is on the outer face, and on the second throw of the dice we see that 4 is on the outer surface. So the outcome is actually 2, 4. Okay. So the total number of elements in E is actually 14. So probability of E is 14 by 36, which is 7 by 18. Okay. Now number 7 and the last one. 2 cards are drawn at random from a pack of 52 cards. What is the probability that either both are black or both are queens? Now from here we can see that cards of spades and clubs are black cards. So we need to draw both cards are black. So black cards are only spades and clubs, okay? Or both are queens. Now let's see the solution. We have the total number of elements in the sample space is 52C2, because out of 52 cards we need to actually draw 2 cards at random. So which is equal to 1, 3, 2, 6 on calculation. Now let A be that event of getting the black cards. So A is the first event. From the question it says that what is the probability that either both are black or both are queens. So the first event is that both are black. Event A is event of getting both black cards. So what is the event B? Event B remains to be both are queens. So event B of getting both queens. Now A intersection B says that it is that event where we are getting both black cards and both queens. Event of getting queens of black cards. Okay. Now NA is equal to 26C2. Why 26? Because out of the 52 cards, the black cards are spades and clubs. So there are 13 spades and 13 clubs. So 13 plus 13 is equal to 26. So there are 26 black cards. Okay. So 26C2 and NB is equal to 4C2. B is the event of getting queens. Now there are actually 4 queens. 4 honors of each suite. So there are 4 queens. So out of the 4 queens, we need to draw 2 queens. So 4C2, which is equal to 6. And A intersection B is actually drawing black cards which are queens. So 4 queen are from 4 different sets. But the clubs and the spades are black. So here is 1 queen and here is 1 queen. So we get 2 queens. Now out of the 2 queens, out of the 2 black queens, we are actually drawing 2 cards. Hence, it is 2C2. Okay. Now, what is PA? PA is equal to NA by NS, which is this. And PB is equal to NB by NS, which is this. And PA intersection B is equal to NA intersection B by NS, which is this. So, since we have studied here that P of A union B is equal to PA plus PB minus P of A intersection B, we can apply the formula here and we can get the probability of getting either both are black or both are queens. Okay? Now I have kept my promise. Keep following. Thank you.